Okay, here we go with 14.6, our first adventure into doing this flip video teaching model, so to speak. Again, remember you can stop the video at any time and rewind it if you want to hear something again, or if you just feel like you need to leave the room and go shout Youthful Cooper, whatever it may be. You have that option, which is kind of nice. So let's go ahead and jump into 14.6. Okay, so 14.6 is entitled Congruent Arcs. We have a number of theorems to go through. We'll go ahead and prove each of them, but again, remember, at the end of the day, what's important is that you're able to apply them and you know them. Okay, fortunately, they all pretty much make sense. So let's go through it. First one, theorem. In the same or congruent circles, if two chords are congruent, then so are the corresponding minor arcs. Okay, well, how would we go about proving this? Well, let's get on the right tool here. If we connect these and connect those, and we also know if the chords are congruent, then we know so are the corresponding minor arcs. Well, don't we also have this and this congruent to this and this? So what would it be? It would be side, side, side. Then central angle by CPCTC, so that angle and that angle, and then we know that the congruent arcs because congruent central angles, okay? So the arcs would be congruent too. All right, moving on to the next one. In the same or congruent circles, if two arcs are congruent, then they're corresponding, what do you think? Chords are congruent. So just kind of going the other way here. So we have the arcs are congruent. How would we go about proving this? Any thoughts on what we might use here? Yes, SAS, excellent. Because if we know, we draw triangles here. Okay, if we draw triangles here, what do we know? Well, if we know the arcs are congruent, then we know these angles are congruent. And we know, because of the same or congruent circles, in this case congruent circles, we know those are congruent, right? So what do we have? We have SAS and then CPCTC to show that the chords are congruent. Okay. Onwards, upwards, we have the tangent secant theorem. Yay! Given an angle with a vertex on the circle, bam, formed by a secant ray right there. I'm sorry, right there, excuse me, that's the tangent ray. The secant ray, tangent ray. Then the measure of the angle is half the measure of the intercepted arc. In other words, this angle right here is half of the measure of that arc. Okay? So, oops. Okay. We are basically trying to prove that x is equal to half of z, because isn't z a central angle, which means its measure is the same as that arc, right? So if we can prove that x is half of z, we're good to go. Okay, so how are we going to do that? Well, don't we know that the measure of x plus the measure of y is equal to 90? Why is that? Ah, yeah, radius to a tangent, right? Okay, great. Well, doesn't that mean that if we subtract y from both sides, x is equal to 90 minus y? Yes. Okay, let's keep that in mind. Don't we also know that 2y, remember, congruent sides, opposite angles, so 2y plus z adds up to 180 in that triangle that's right there, right? Which means that what? Z is equal to 180 minus 2y. Look at that. Look at that. Okay. If we divide both sides by 2, we get z over 2 equals 90 minus y. Notice how x equals 90 minus y, z over 2 equals 90 minus y. Well, what does that mean? Doesn't that mean that x is equal to 1/2 z by substitution? Beautiful. Okay, let's take a look at an example here. And I apologize, I know I keep jumping in and out of the screen, you can't see me, but I wanted to get the board close in as possible. So, what's the measure of that angle? Well, if the arc there is 120, that's gonna be, yes, very good, 60, awesome. All right, next slide. Next theorem. The measure of an angle formed by two secants of a circle intersecting inside, that's underlined, you might want to underline that, the circle is half the sum of the measures of the arcs intercepted by the angle and its vertex angle. So, let's say we were talking about angle DKB. We're trying to show what? That it's equal to half of the sum of the measures of the arcs intercept by the angle, that would be measure of arc DB, and its vertical angle, which would be AC. So half the sum of arc DB plus arc AC is what we're trying to show. Okay, so here's the proof. The measure of angle DKB, isn't that equal to the measure of angle B plus the measure of angle C? Why would that be? Think about that. Yes, it's an exterior angle, and we know an exterior angle is equal to the sum of the remote interiors. Angle B and angle C are remote interiors. Okay, we also know that the measure of angle B is half the measure of arc AC. Why? You should know that one, right? Isn't that angle going to be half of that arc, right? And isn't the measure of angle C half of DB, arc DB? Okay, well, therefore, doesn't that mean that if the measure of DKB, since it's equal to the measure of B plus C, would be equal to 1/2 the measure of arc AC plus half the measure of arc BD? In other words, we did substitution. So you have measure B plus C over here, B plus C over here. We did substitution. Okay, well, all we have to do is factor out the 1/2, and then there we have it. It's equal to half the sum of arc DB and arc AC. Okay? All right, let's practice that. Again, you can always stop this, try it on your own, and then we can go through it. So here we have to find the measure of angle 1, and you're told that that is 26, and that is 48. What would you do? Well, it's equal to the measure of angle 1 would be equal to this one plus this one divided by 2. So 48, 26, and divided by half. So it's, anyway, that's 74 divided by half is 37. Hopefully that's what you got. Okay, here's another practice one. Ooh, a little different here. Here we actually have the angle 36. We have one of the arcs. We got to find the other one. What equation would you set up? Try it. Remember, you can always pause. Okay, well, isn't 36 going to be equal to half the sum of this plus this? So 36 is equal to half of the sum of x plus 48. Solve for x. 24. Okay, good. Next one, this is from page 479, the one that they put in the problem set. Love when they do that, I'm kidding. Okay, the measure of the angle formed by two secants intersecting in a point in the exterior of the circle. So we have interior before, exterior here, okay, is half the absolute value of the difference. So before it was sum, when it was inside, here outside, difference of the measures of the intercepted arcs. So what we're trying to say here in this scenario is that this is angle 1 right here. That angle 1 is equal to half of the absolute value of BD minus AC. The measure of arc BD, measure of arc AC. Or vice versa, because it doesn't matter, we're taking absolute value, right? So if it's a negative difference, when we take the absolute value, it becomes positive. Okay, so how are we going to prove that? Well, I've added in here this segment. I've called this angle 2. It's hard to read, but that's an angle 3 right there. Okay, so we have angle 1, angle 2, angle 3. All right, isn't it true that we're trying to prove the measure of angle 1 is equal half of the absolute value of the measure of arc BD minus the measure of arc AC? Okay. Isn't it true that the measure of angle 2 is equal to the sum of the measures of angles 1 and 3? Why? Exterior angle theorem, okay? Great. Lovely. And we also know that the measure of angle 2 is going to be half of its intercepted arc, right? So we know that measure of angle 2 equals 1/2 of the measure of BD. All right. So moving along. Isn't it true that the measure of angle 3 is half of arc AC? Again, same reason, right? Half the measure of its intercepted arc. Okay, well, wouldn't that mean that half the measure of BD is equal to the measure of angle 1 plus 1/2 the measure of AC? We've done substitution. So if you look here, I've got half the measure of arc AC is equal to angle 3. And I've got that angle 3 is equal to, or angle 2, excuse me, is equal to 1 plus 3. And 3 is equal to half the measure of AC. So you can do that by substitution. So 1/2 the measure of BD is equal to the measure of angle 1 plus, what are we going to do? We're going to subtract, right? What I did was I subtracted here and then just flipped the sides just to make it easier to see. And then can't we just take out the half, factor out the half? And I don't think I put that up there, but there's the proof for it. So again, bottom line is that when we have two secants intersecting a point in the exterior, the measure of that angle is going to be absolute value of this arc measure minus that arc measure, or vice versa. Okay, so let's find the measure of angle 1. Go ahead and try it. Okay, so when it just be, and again, you can pause anytime, so if I'm going too quickly, that's okay, you can pause. 47 minus 15, half of that is half of 32, and obviously I did it the bigger number minus the smaller number, so I don't need to worry about the absolute value, but if you did 15 minus 47, you would have negative 32, but the absolute value of that is still 32, and half of that is 16. Okay, this one's a little bit more challenging, give that one a shot. Here we have the measure of the angle. Think about what equation you can set up. So wouldn't it be 20 is equal to half of, if you take the bigger one, you don't really need the absolute values, 58 minus x. Okay, then basically solve that. So we would distribute, half of 58 is 29, half of x is negative 1/2 x, and then you could go from there. So I subtracted 29 from both sides, so 20 and negative 29 made negative 9. And then to get x by itself, when I multiply by the reciprocal here, which is negative 2 times negative 9 is 18, which obviously makes sense because it's a positive measure. It's got to be positive. Okay, terrific. I think that covers it. And so you'll now go and try the homework. You look for that on Schoology. And of course, I'll take any questions on this when we meet in class online next time.